Gravimetric titration. Gravimetric titration, if we are going to separate gravi and metric, it means we are going to weigh and measure. Okay, so we are basically measuring the weight. What is it? So, gravimetric analysis describes a set of methods used in analytical chemistry for quantitative determination of an analyte or the ion being analyzed based on its mass. The principle of this type of analysis is that once an ion's mass has been determined as a unique compound, that known measurement can then be used to determine the same analyte's mass in mixture as long as the relative quantities of the other constituents are known. This is according to Wikipedia. So, what is really an analysis and titration? Okay, so what's the difference between gravimetric analysis and gravimetric titration? Okay, so if we are going to talk about gravimetric analysis, it is a classical technique for determining the mass of an analyte through precipitation. So, if we are going to talk about titration in another form of gravimetric analysis, it is a quantitative analysis method used to determine concentration of a substance in a solution by adding a standard or the titrant and monitoring the result of the chemical reaction. Acid-base titrations are among one of the common titration experiment. Okay, so based on my observation, if you're going to talk about gravimetric titration, since we are using a known compound, for us to be able to get the mass of the analyte, we will have to add the known compound. Okay, so if for example we have a molar of this particular compound, okay, blank molar of this particular compound, so we are determining the molar of that particular titrant. Okay, so we are not basically doing the titration as what you have observed, that we do not use the burette for the titrant and then the conical flask for our analyte. um, for gravimetric titration, this is just the direct addition of our known concentration. That is what we are talking about gravimetric titration. So if we are going to do gravimetric analysis, we are determining the mass of the analyte through precipitation. So precipitation method in gravimetric titration or analysis is the um, most common type of gravimetric titration that we are going to use. So, what is the difference between volumetric and gravimetric analysis? Definition: a type of quantitative analysis in which we can measure the amount of a known compound using its volume. For gravimetric analysis, it is a type of quantitative analysis in which we can determine the weight of the unknown compound in a sample. Okay, so if we are going to determine the volume in volumetric analysis, for gravimetric, we are going to determine the weight of the unknown compound because it is in a precipitation form. So it is a solid particles that we are measuring in gravimetric analysis. Basis of volumetric analysis measures the amount based on the volume. So for our gravimetric analysis, measures the amount of compounds based on the masses. Units of measurements, we have liters, ml, and then M3 or dm3. And then we have for gravimetric, we have milligrams, grams, and kilograms. Okay, so we have the chemical reaction in volumetric analysis involves chemical reaction which can change the color of the sample. So as you can see, we have been talking about volumetric analysis in our previous discussion. So by the addition of indicator, it helps you to determine the end of titration process. But for the gravimetric analysis involves the chemical reaction which precipitate the desired compound. Okay, so again, we are the most common method that we are going to use is the precipitation method of gravimetric analysis. So you will be able to observe precipitates in your compound. Gravimetric analysis introduction. So, a technique in which the amount of analyte in a sample is determined by converting the analyte to some product. Mass of the product can be easily measured, and then analyte, the compound or the species to be analyzed in a sample. And then overall, gravimetric sounds simple. The advantages of gravimetric analysis when done correctly is highly accurate, most accurate of all time, and requires minimal equipment. The disadvantage requires skilled operator and it should be done slowly. Steps in gravimetric analysis. So first, we are going to weigh the sample to be analyzed. Next, we have to dissolve the sample in water. We have to dissolve it until it becomes a solution. And then letter C, we have adding a suitable chemical to form a precipitate. So this is what I am talking about, that we are going to add directly the known concentration. So D, we are going to filter and collect the precipitate. And then E, repeated drying and weighing until a constant mass of precipitate is obtained. This procedure is especially suitable for determining of metal ions and anions such as sulfates. So here you will observe a solid soluble salt containing a lead ion and other chemical species. Okay, so we have here step one, we have to dissolve our solid soluble salt that contains lead, and then we have an addition of our water, and then after dissolving it there will be a mixture of our molecules in the solution. So step three is to filter and weigh the solid. We have lead sulfate, so solid of lead sulfate and solution of the other chemical species, and the leftover of our sulfate will be measured. So now we have the step-by-step gravimetric analysis method. Okay, so I had this idea of doing this kind of presentation so that you will be able to understand what is really gravimetric analysis is. Okay, so first thing, we are going to prepare our materials needed. And then as you can see, we have their laboratory weighing balance, and then we also have the crucible. Okay, so the crucible, before we are placing it to the desiccator, we're going to dry it off in the oven, okay? So that there will be no moisture present in the crucible. So we have to remove the excess moisture that has been absorbed in our desiccator. After some time, we have to remove our our crucible from the oven and then place it in the desiccator. Okay, so what is the purpose of our desiccator is to cool down the crucible and then to prevent moisture absorption from the environment. Okay, so that if you're going to weigh the crucible, it will be specific to its weight. And then we also have to weigh um, the metal carbonate that we are going to use during the gravimetric analysis. Okay, so we have to place our crucible in the laboratory weighing balance using our crucible tongue, and then we have to tare, and then after which we have to add about 2 grams of unknown metal carbonate. Okay, so the metal carbonate, it can be group 1 metal carbonates. We have lithium carbonate, potassium carbonate, and sodium carbonates. Okay, so again, after tearing it, we will have to add 2 grams of our unknown metal carbonate. Okay, and then we have to place our desiccator or heat up the unknown metal carbonates for about 3 to 5 minutes using the Bunsen burner. Okay, so what is the purpose of that? We have to also remove the moisture present in our metal carbonate, or we have to remove the other metal ions present in our metal carbonates. Okay, so we have to place it in a Bunsen burner for about 3 to 5 minutes. Okay, and then after which we have to cool down our crucible with the metal ion or metal carbonates, and then place the crucible plus the non-metal carbonate in the desiccator to cool down and not absorb moisture. So it prevents absorption of moisture from the environment. After that, we are going to weigh the mass of our metal carbonate. So record the final mass, and the final mass for our crucible, I mean the metal ion, is already 1.82 grams. Okay, so as you can observe, we are measuring, in the first step we are measuring about 2 grams of our unknown metal carbonate, but since we heat it up, and then other metal ions that are not necessary for the um, gravimetric analysis have been removed, and also the moisture. So it decreases from 2 grams to 1.82. So this will be the final mass of our metal carbonates. And then we have to also prepare our two beakers. So we will be able to add the water and also um, the liquid that we are going to add. So here we have pour the metal carbonate to the water and stir until it dissolves. Okay, so again, the metal ions that we have prepared, we are going to place it in the water about 200 ml, and then we have to stir it continuously to be able to dissolve. Okay, and then we have also prepared 125 ml of calcium chloride. Okay, so what happens next after it dissolves? So we will add our calcium chloride to the solution. So what will happen if you're going to add our calcium chloride? Okay, so at your right, you will be able to see a precipitates. Okay, so precipitate is already forming. Okay, so from clear, it becomes cloudy white. Okay, so because the precipitate is already forming. Next, we are going to prepare for vacuum filtration. So we have to prepare the materials we need for vacuum filtration. Okay, so we have the filter paper, we have the funnel, the conical flask, and then the vacuum, and also your stand, the one that is holding your conical flask, and also your funnel. So we can use the burette stand. Okay, so what you're going to do next, since we will be using the filter paper to collect the precipitates, we will have to get one of the filter paper, and then we are going to weigh the filter paper. Record the weight of our filter paper, that is 0.90 grams. Okay, after which we are going to place our filter paper in the opening of our funnel, okay, or the mouth of our funnel. So place the filter paper into the funnel. After placing the filter paper into the funnel, we are going to add a little of the deionized water to settle the filter into the funnel. Okay, so deionized water is a type of drink which removed all of its ions, and it has no charge. So again, deionized water has no charge. So we will add, I think, few drops only, so that it will be able to settle, I mean the filter paper will be able to settle into the funnel, and then pour the solution to separate the precipitates and the liquid solution. Okay, so the solutions that we have added, we have the metal ions, we have the water, and also the addition of our calcium chloride. Since it already forms a precipitate, we are going to separate them. Okay, so pour the solution to separate the precipitates and the liquid solution. After that one, we have to turn on the vacuum filter to vacuum water out of the precipitates. Okay, this is like a catalyst in our procedure. So it vacuums the water out of the precipitates. Okay, so while pouring, we have to turn on our vacuum. Next is pour a little of the ionized water into the beaker to wash out the solid precipitates left in the beaker. Because if you are going to pour it all together in the conical flask, you will observe small particles left in the beaker. So we have to again remember with this gravimetric analysis or titration, we are going to collect the precipitates. Okay, so that we will be able to accurately measure the weight of the unknown compound. Okay, so what we're going to do is to add a little of our deionized water and then shake it and then pour it again to the funnel. Okay, so pour a little of the ionized water into the beaker to wash out the solid precipitates left in the beaker. Slowly shake the beaker and pour it to the filter to collect the solid precipitates. So after which, we have to remove the filter paper with the solid precipitates. Okay, so again, after pouring everything, we have to remove our filter paper with the solid precipitates in the funnel and place it on the watch glass. Okay, after placing it on the watch glass, we are going to place it in the oven. Okay, so do not weigh the precipitate yet. We have to dry it first because there is moisture present in our precipitate. So we have to dry it first. So do not weigh the precipitate yet. Dry the precipitates using the drying oven. Again, do not wait the precipitates. Dry the precipitates using the drying oven. So place the precipitates in the oven to dry the moisture. Okay, after 15 minutes, check and remove the solid precipitates from the oven. So if there are big chunks of solid formation in our precipitates, break down into smaller particles using the spatula. Place it back for about 5 minutes. Okay, why we have to separate the big chunks of our solid precipitates? Because it means to say that there is moisture present in our chunks. Okay, so we have to separate it using our spatula, and then we have to place it back for about 5 minutes to completely evaporate the moisture present in our precipitates. So next we have place the filter paper with the precipitates and calculate the final mass of the solid precipitates. Okay, so after drying, we have to place our filter paper with the dried precipitates, and then we have to determine the weight. So filter paper plus the sample or your precipitates is equal to 2.65 grams. So remember, before doing this process, we have we have already weigh our filter paper. So on your left, you will see their filter paper plus the sample. Again, we have 2.65 grams. So since we are going to determine how much precipitates is produced with our gravimetric titration. So what we're going to do is to subtract the weight of our filter paper. So since we have 2.65 grams minus 0.90 grams, we have a total of 1.75 grams of calcium carbonate produced. Okay, so that will be the final answer. Types of gravimetric analysis. So there are four fundamental types of gravimetric analysis, of which there are two common types involving changes in the phase of the analyte to separate it from the rest of a mixture, resulting in a change of mass. So first we have the volatilization gravimetry. So volatilization involves separating components of our mixture by heating or chemically decomposing the sample. Next, the most common one is the precipitation gravimetry. Precipitation gravimetry uses a precipitation reaction to separate one or more parts of the solution by incorporating it into a solid. Next, we have our electrogravimetry. Electrogravimetry is a method used to separate and quantify ions of substance, usually a metal. Next, we have our thermogravimetric. So it is a method of thermal analysis in which changes in physical and chemical properties of materials are measured as a function of increasing temperature or as a function of time. So what are the applications of gravimetric analysis? In analytical chemistry, gravimetric analysis is a way of determining the analyte quantity based on the density of a solid. Example, measuring the solid suspended in water sample. So how much solid present in the water. Okay, so the collected solids are weighed until a known water volume is purified. So that ends our discussion for gravimetric analysis. Thank you.